Hello everyone. Today I'm going to be solving a hard problem that is famous. Okay, I heard about it as a problem that might take a month to solve, and that it's very tricky, and also that if you haven't never seen the solution for it, then you won't be able to solve it. So I'm in the situation where I have never seen the solution for it. I obviously solved other meeting rooms problems, but this is meeting rooms 3, a hard problem. I have no idea what this is about. Let's try. I will spend about 40 minutes on this. If I don't succeed, I will just don't bother and move on. Okay, so we are given an integer n. There are n rooms numbered from 0 to n minus 1. Okay. You are given a 2D integer array meetings, where the meetings is start end. Okay. Meetings is list of integers, where each of the internal lists is just two values, two integers, start and end. Yeah, I will assume that this will be an integer. It's not explicitly said here, but it shouldn't change the problem. All the values of start are unique. Okay, so start's unique. Good to know. And a meeting will be held the half-closed interval. Okay, so start end. Okay. Meetings are allocated to rooms in the following manner. Each meeting will take place in the unused room with the lowest number. If there are no available rooms, the meeting will be delayed until a room becomes free. The delayed meeting should have the same duration as the original meeting. When a room becomes unused, meetings that have an earlier original start time should be given the room. Return the number of the room that held the most meetings. If there are multiple rooms, return the room with the lowest number. Okay, so I will be returning a room number that held the most meetings. So rooms are integers, I will be returning an integer. Interesting problem. Let's see how it works. So for example, let's say we have meetings, we have just one room, and we have meetings that are 1, 2, okay, let's say 1, 3, 2, 3, 2, 4, 3, 5. Okay, so we just have one room. So for this one room, there will be hours. Let's say there is a room, then there are hours, which is 1, 2, 3, 4, 5. So when we say that the meeting will be held between hours 1 and 3, it means that, okay, so first room, and let's say there is like the first meeting, 1, 3, how do I show this? Okay, so let's put it like this, right? So 1, 3, 4, 5, 6, 7. 1, 3, 3 is non-inclusive. So we hold this time. Then this room will want to start, this meeting will want to start at 2, but it won't be able to. And because of that, we will need to move it. And then the third meeting will also want to start at 4, but it won't be able to. So we will have to move it. Oh, 3, 5, sorry. We'll want to start at 3. So we have those 3 meetings. Let's see how we resolve this conundrum. So we have kind of like a priority queue, I think, which we populate with meetings, and all the starts are unique, which is interesting. So we for each start, we can have just one room corresponding to that start. The meeting will be delayed until a room becomes free. So the delayed meeting should have the same duration as the original meeting. That's interesting because we know that there will be a moment when some room becomes available. Once the room becomes available, we will have, I wanted to say that we will have at most one meeting that starts a specific start time, but no, we can already have several meetings in our priority queue with different start times that can be added to this particular room. Then that's one problem. Another problem is that there can be longer and shorter meetings. Maybe I should, yeah, I will create a different test case for when we have longer and shorter meetings. So when a room becomes unused, meetings that have an earlier original start time should be given that room. It sounds like we have two regimes. One is that all meetings can start on schedule, and another when some of the meetings cannot start on schedule and they are getting added to the priority queue, and then we need to track the first moment then the room becomes available. And since by design of this problem, there can be a meeting that can perfectly fit there, but if there is a meeting that should have started earlier, it will be assigned to this particular room. And also, we don't really care about the rooms, but we are assigning from rooms with lower number. Yes, assign the room with the lowest number. So we are assigning the room from the lowest number to the highest number. Okay. So for this particular problem, what will happen is that we have the first meeting here, then the second meeting, the first meeting, then we will hold the second meeting, and finally we will hold the third meeting, and it will take us the whole of 6 hours to hold all of these meetings. Okay, let's figure out some trickier example. So let's say we have meetings of different lengths, and let's say, for example, here we have a meeting of 1-4, but then, and we have 2 rooms, and we have meetings of like a meeting of 2-3, and then we have 2-5. Oh no, we cannot have 2 meetings starting at the same time. So 4-3-5 is 3-6, and then let's say there is 4-5. Okay, so we have 1-4, which is this meeting. Then we have 2-3, which is this meeting. Then we have 3-6, which is this meeting. No. And then we have 4-5, which is this meeting. And we have 2 rooms. So when we have 2 rooms, we first assign meeting to the first room, and then we assign meeting the second one to the second room, and then the next meeting will actually start here, and it will start on time, but then the last meeting will not be able to start on time, and the first room will be available first, so it will start here, and then both rooms have the same amount of meetings held. Okay, So how do we approach this problem? Solution. So let's first discuss a brute force solution. Let's say we keep a list of integers. I'm not sure if like this is the brutest force possible, but let's say there is like for each room availability true, etc. So we have this availability, and once we add any meeting to the room, it stops. We change the availability. So availability flip on starting a meeting. And then also let's change how we formulate this. So on starting a meeting, assign a room by traversing the array, then doing availability flip, then doing adding and to min heap. So basically we will be popping and stuff like this, and room added to min heap. So then we can pop this and room once it becomes available. So when the room becomes available, there are two possible scenarios. Yeah, okay, I see what's going on here. This will be the biggest problem in the default solution, like whether there is a room that is that we can assign in this part of the array. So let's focus on this later. We will have also a time. The time will be moving forward, and there can be two triggering events. So one triggering event will be that there is a new meeting happening, the new meeting start, or there will be another triggering event that a previous meeting has ended. So to new meeting start, or meeting ended, so room empty. Okay, then we are basically moving across time. There can be several meetings ending on the at the same moment of time, and then there can be just one meeting starting at a specific moment of time. So we can keep two arrays. One will be like for meeting ends, we will have min heap. For meeting starts, we can just iterate, we can sort all the meetings. So we will sort all the meetings, and then we will iterate over this meeting array from start to finish. And we can use, for example, like reverse the meeting list after we, or use double-ended queue, or take the list of meetings and reverse it as a stack so that we can just pop the meeting from the stack. So then we will just need to figure out what is the next event between these two, because we can also traverse the whole timeline, but it can be that meetings can have very, very long times. So we don't want to try each time and see if something is happening at this moment of time. But yeah, so then if the meeting has ended, we are updating availability array in O of 1. And if then we also keep track of delayed meetings, which is DQ of delayed meetings, since all meetings start at different unique times and we are iterating from earlier meetings to later meetings, we can just keep those in double-ended queue. And yeah, so there will be 3 sources of events. Oh no, there won't be 3 sources of events. We are only manipulating this delayed meetings queue if a meeting has ended. We are checking if there are any delayed meetings, and we are assigning a new meeting to the spot that was just emptied. Otherwise, we are adding this. Yes, so if there is a meeting that has ended, we are checking this delayed meetings queue, adding the meeting to the room that has emptied, and we also have the counter for assignments of meetings to rooms, so that in the end we can return the right value of which room had the most meetings. Now, let's go again to what I mentioned before as 2 regimes, right? Either this delayed meetings queue is empty, so then when the new meeting starts, if we have a room available, we add it to this room, and we go through this process on starting meeting. If there are no rooms available, so availability is false everywhere, then we are adding it to delayed meetings. And appending it to delayed meetings, and don't do anything else. We are waiting until the next room empties. And we are choosing whichever is the earlier thing between these two, and we are prioritizing meeting ends, because if meeting ends on the same time, then another meeting starts according to the rules of this problem. Since the interval is half closed, we can start on the same time when we end another meeting. So we first empty the rooms that can be emptied at this moment of time, and then we populate it with meetings. And we prioritize earlier meetings. So this all works. And why is this a brute force solution? So let's think about how fast will this be. So n rooms, m meetings. Then what do we do on each step? So for each meeting, we are iterating over each meeting. So for each meeting, we are even sorting those because they are not sorted by default. So it will be m log m plus. What do we do next? We go and we choose that meeting, like on the meeting start, we are assigning it to any available room. So on the meeting start, we are either assigning this to an available room, which can take O of n time, or we can, if this room is unassigned, then we add it to the delayed meetings queue, which is O of 1. So we do, for each of the meetings, we can do up to n iterations to find the first empty room, or we are adding it to delayed meetings queue, which is O of 1. So if it's O of mn on meeting start, so then on meeting end, we will have m meetings that are ending, and then when meeting ends, we need to pop the element from the meeting ends, so m log m, and then we need to update the availability, which can be done in of1, and then we need to find to possibly pop delayed meeting from the delayed meetings queue and assigning this to assigning it. So it will be possibly m times we will do of log m, and if we need to assign it again, we will need to do n operations to find the availability, because several meetings can be can end on the same at the same moment of time. So we first iterate through all of those. We can also do this faster. So what I was thinking, right? First, we go through all of the meetings that are ending, and let's assume that their order is arbitrary. So we don't know, there can be like 5 rooms emptied at the same time. And then we have 5 delayed meetings that need to be assigned to these 5 spots. So we can just wait for this, for all the rooms to empty, and then start assigning the meetings. But what if we create a heap in such a way that we also start with the room with the smallest number that is emptying? Then we can assign right away, and we know what is the smallest room, because if our queue delayed meetings queue is not empty, it means that there are no empty rooms right now, no available rooms right now. So whenever the room empties, then we can just assign to this room, because this will be the earliest possible room. And then we can do all of this instead of like traversing the whole array. We can do it in of one, both ending the meeting and starting a new one. But yeah, it's not hard, so let's do it this way. So plus m log m iteration operations, and then finding this will be of n operations plus n to find which room had the most meetings. Okay, in terms of space, I didn't simplify this, but it will simplify to, okay, so n, if it's bigger than log m, then it simplifies to mn. If n is smaller than log m, then it simplifies to m log m. And in terms of space, we are keeping, it will be of m plus n, I think. So we are keeping data structures that keep all our meetings stored, possibly up to all our meetings, and we have a data structure that has availability for each of the rooms. So these two, and depending on which one is bigger, then it can be just one of those. Okay, so as you can see, this is the biggest blocker of our algorithm so far, if I'm not missing anything. So how to assign an earliest room that is available if we have several available rooms. Right now, we are just traversing from the start of the array. I think there is a cleverer solution that uses trees. So I think it's called segment tree, and it can surface whether some subsegment of the tree has any values, any empty spots. And we can try to do a binary search. So it finds if there is a empty spot in log n time, and then we can do a binary search doing log of n operations to find where is this smallest available room, and then it will be log squared of n. operation instead of this n. So m times log squared of n, I think, is also an option, and maybe there is some more clever solution, but let's just leave it at that. Let's just implement the simpler solution without segment trees or anything. And let's start. So implementation. Oops, wrong button. Okay, so availability will be true times n. So we start by having the whole everything is available. How should I write the function? Because I want to write some sub functions, for example, like find the smallest available room, because we'll need to do it several times. I'm thinking whether I should write it as a method or as a sub function. I will figure it out later. So availability, and now we have also delayed meetings, which is the queue that starts as an empty one. And then we have ends, which is just an array, and it also starts as an empty one. Okay, then we also need to reverse our meetings. So meetings, okay, meetings sort, and key equals lambda x minus x minus x0. So we only need to sort by the stars because all stars are unique, and we are sorting in such a way that we can just pop the next meeting from the queue. And then how do we know that we still have meetings to assign? I might need to update this once I write the algorithm. But so far it looks correct. Okay. So now what? Now while meetings or delayed meetings. So if we have meetings that are still unassigned, oh yeah, and let's also have counter, which will also be a list of size n. While meetings or delayed meetings. So if we still have meetings that haven't been assigned a room, we are continuing to iterate. So now we need to figure out what to do. If not ends, then we go all rooms available. I will populate it later. And so we have ends, but we don't have meetings. And since we are operating, then it means only delayed meetings left. And finally else. So we have both ends and meetings, and we might have delayed meetings. Some running. meetings and some unassigned, some not started meetings. Okay, so this will be 3 possibilities, and overall this will be m iterations here, and we will see what happens inside if we need to update our running time. Okay, so if node ends, all rooms are available. Let's write a function that gives us def choose the smallest available room. Choose room. And we are iterating for in for I room in enumerate availability if room let's call it room available. If room available, return I and then return -1 if there are no available rooms. Returns the smallest index of available room. The smallest available room index, I don't know how to say that, or -1 if no are available. Okay, so if node ends, room equals choose a room, and then if can there be 0 rooms? Let's assume there cannot be 0 rooms. So all rooms available, room choose room if room cannot be -1 here because we know that there are no ends, so definitely there are rooms available. Actually, all rooms are available. Actually, here we don't even have to choose the room. If all rooms are available, then we can just say that room equals 0 and availability 0 equals false, and ends heap queue heap push. Okay, if not ends, let's actually start from a different thing. Let's choose the next meeting. If delayed meetings, which would be strange. It means that like all the rooms became available just now, but it can theoretically happen. So let's just do this. If delayed meetings, then we do next meeting will be Yeah, we will also need to know what is the current time. So if here the current time will be the start of this meeting. So, but delayed meetings, it would be a strange situation, but it's still possible that we have something like this happening. So I think we will have to assign the room that was just emptied. So this means that here all the rooms are available. Here we will never have delayed meetings. So the next meeting will be meetings pop. Next start, next end will be meetings pop. And room will be 0. And availability of 0 will be false. And heap queue, heap push will be pushing room number 0. Yes, so we also need to push in the right order so that the smallest end with the smallest room number is out first. So, but here it will be straightforward. It will be next end and room number, which is 0. But I think the API is that we do this. So first we choose the heap, then we push to the heap. Okay, now this is done. Let's say we have only delayed meetings. So there are ends, but there are no meetings. There are only delayed meetings. So now current time and room number, let's just call it room for consistency, will be heap queue, heap push of ends. Okay, so current time and room, we do this. Oh, heap pop, sorry. That's obviously not what I meant. Heap pop, and now we know current time and we know that there are no meetings, but there are some delayed meetings. So now we do next start, next end will be delayed meetings pop left. And now we need to find, oh no, we know the available room. It's the room that we have just popped, because we will be popping first the smaller rooms if there are several rooms ending at the same time. Then current time room. What do we need to do? We now need to do the update. Availability will stay the same, so basically it flips one way and then it flips right back, so we don't need to do anything here. We just need to do heap queue, heap push, and the difference here is that we are pushing to ends, but next end will be not this. Next end will be current time plus next end minus next start. So just to check ourselves, let's see, for example, here. We will be popping here 3, right? So we have popped 3, and now we are taking this from delayed rooms, or maybe, yeah, currently the rooms, the meetings will not be empty because we have this last one, so maybe we should do something different, but doesn't matter. For now we just want to calculate what will be the correct end time. So end minus start for this room will be 4 minus 2, which is 2 hours, which is correct. So now we have 3 as the start time. 3 plus 4 minus 2, it will be 3 plus 2, 5. So now if this meeting starts at this point of time, it will be until 5 and 5 non-inclusive. So this is correct. Correct end. Okay, now finally we have situation where we are sure that there are some meetings that have not ended, have not been assigned. Oh yeah, I think I'm forgetting to update the counters, right? So here, counter 0 plus or equal to 1, and then here counter room plus or equal to 1, and then here we will do what? We will figure out what happens first. Does it the next meeting does it the next end that happens first or not? So fortunately in heap we always have the closest element in the 0th place, so we know that ends are not empty, so we can just look at it. And next end, okay, let's do this. If ends 0 and 0, this is current end, is smaller or equal to meetings minus 1 and start. So if the end happens at the same time or earlier than the next meeting start, then we are processing it as another end. And now we need to assign a room. So okay, so there is a meeting ending now, else new meeting starts. So if there is a new meeting ending, there might be some meetings in the delayed queue or there might not be. So first of all, we are processing the delayed meetings. If delayed meetings, it means that there are some delayed meetings. Then we will, like, this meeting is ending, so we will just do the same thing as here. Probably should extract this as a function or something, but let's check that this is correct. So we are popping, yes, this is current time. So next start and next end is the delayed meetings. So we have delayed meetings. They will definitely have smaller start time than whatever is in the meetings right now, because to be added to delayed meetings, you first need to be popped from meetings, and meetings are sorted. Now, next start, next end, heap queue, heap push ends, and current time plus next end minus next start. Okay, so this looks correct if there are delayed meetings. Else, so if there are no delayed meetings, then we might not have any meetings to assign to this room, which is fine. We just need to update its availability. So it means that we do that. We can theoretically also just compare the ends time to the next meeting's time, and if they're equal, we can also pop the next meeting and just assign it to this room. If there are no delayed meetings, we know that this one will go in this particular room, but that also might not be the case, because there might be a room that is has the smaller, yeah, there is a meeting ending, and then there may be a meeting starting at the same time, but maybe the meeting ending is for the only one unavailable room, and there are all the other available rooms with smaller IDs, so we don't need to assign the new meeting to this room here. It might need to be assigned to another room. So here it means that we don't do anything, and this is important in terms of runtime complexity. So here we are doing an end, which is a separate thing than, like, it means that not on every turn here we are popping either meeting or delayed meetings, but there can be at most the same amount of ends as the meetings themselves. So in total, there will still be not more than O of M loops in total. Okay, now let's get back. So if we are just popping an end, then we do current time room heap queue heap pop ends, and what it means for us. So we do availability of room changes to available room true. And anything else? No, I don't see that we can need to do anything else here. So meeting ending now. Now the new meeting starts. So next start is and next end will be meetings pop. So now room will be choose room. If room equals -1, it means that no available rooms, and that means that this meeting just goes to delayed meetings queue. So again, another thing that can happen that doesn't decrease on some loop iteration, doesn't decrease the amount of either meetings or delayed meetings, because it just goes from one to another, but there can be at most m such operations, so it doesn't increase our running time, at least the one that we have calculated so far. So if room is equal to -1, there it means that there are no available rooms, and we add our meeting to delayed meetings. So delayed meetings append, and we are appending next start, next end, and it will definitely be definitely start later than any meeting in the delayed meetings so far, because it was popped later from the meetings stack. Else, now here we know that there are some rooms available, and this room available with the smallest index is the room. So what do we need to do? We need to assign this room to this meeting. So availability room is equal to true. Count room is plus or equal to 1. What else? We need to update our ends. Oh, availability false, obviously not true. And heap queue heap push ends. So next end, yes, currently a new meeting starts and there is some available room, so we were able to choose it. We are just adding this, and the end will be correct. Okay, count room is plus or equal to 1. Ends become a little bit bigger. Okay, so that's it. Then here we will be returning max counter. Wow. So let's now finally reason about our running time. We are doing of m iterations. Why is that? We have meetings, and meetings can flow to either delayed meetings or to ends, like to started meetings, let's say. If and then delayed meetings can also just move to started meetings, basically to ends heap queue. In this scenario, we know that at most each of those operations can happen at most m times. So at most there will be m total loops, total loop iterations here. And then inside of these loop iterations, what's the biggest possible thing that we do? Okay, so first of all, we still do m log m operations to sort, but then inside those loops, heap queue, heap push ends can be at most log m plus if there is something else. So delayed meetings, heap queue, heap pop, heap queue, heap pop, delayed meetings, and like appending and popping left from DQ is of 1. So here the biggest time then becomes this choose room, where, yep. So this of log m plus n. Otherwise, and just to be clear, operations with double-ended queue is this. So then let's just simplify this. It will be of m, and then will be log m plus n, and 1 will be ignored. And yes, there are two pieces like this. Log m plus log m simplifies to log m. So either that or log m plus mn. I think this is a simpler writing of this, and yes, this comes down to the same thing as before. Now, how much time have I actually spent on this? 52 minutes. That was a huge problem. I think I would also need to test this on some example. Let's just test it here. I think with 2 rooms it will be a longer one, but yeah, let's try to quickly iterate through this and see if we have some issues. So there are 2 rooms. Availability true, true. Counter will be 0, 0. Delayed meetings is DQ, which is empty. I will just keep it this, ends is empty. Meeting sort, so we will sort them essentially from the smallest to the biggest one, and in reverse, but then we will be popping from the right side. So essentially we are just popping things from the left. Let's think about it this way. Then while meetings or delayed meetings, we do have meetings, so these are not empty. If not ends, we are exactly at the situation where we don't have any ends, all rooms available, that's true. Next start, next end, meetings pop. So next start is the meeting, this 1, 4, and room is equal to 0, so this now becomes 1, and heap queue, heap push ends becomes 4 for room 0. And then counter and availability becomes false. Okay. Availability ends counter. Okay. Now we have finished this and we are not getting into any other branches. We are continuing here. So meetings or delayed meetings, yes, there are still meetings. Now the next meeting is 2, 3. Not meetings, no, there are meetings, and there are now ends, so we are going here. So ends is smaller than meetings. Okay, so meetings 4 is not smaller than 2, so we are going in this branch. Next start, next end is meeting pop, so it will be 2 and 3. Room will be choose room. So choose room. For room, we are iterating over availability, it's false, and we are returning it on the second iteration, and we will be returning 1. So here we will return 1, and the room is not -1, so availability room will become false, counter for room will +1, and ends, where we will be pushing another thing for the ends. Good, so we are pushing here, and which is 3, and it means that 3, 1 becomes the earlier thing in our heap queue, and counter for this room also becomes 1. And this becomes false. Okay, let's do the next iteration. So now meetings or delayed meetings are still empty, but meetings is not, ends is not empty. Okay, something is going on, so I will need to stop, but let me just check if this is correct implementation. Okay, it's not correct implementation. I will figure it out later. Thank you, everyone. See you.